Let's talk about writing equations from a point and either a parallel or perpendicular slope. First, what do we know about the slopes of parallel lines? Hopefully you know from past experience that slopes are equal when the lines are parallel, which should make sense since parallel lines are going in the same direction and slope is simply a direction. How about perpendicular lines? What do we know about their slopes? Slopes of perpendicular lines are opposite reciprocals, which means opposite signs and flipped fractions. So opposite, of course, one is going to be positive, one is going to be negative, and flipped fractions would be like 1/3 and 3/1. One fraction is going to be the exact mirror image, basically, of the other. So if I have an equation y equals 1/2 x minus 4, what's the slope of this line? Always look for the coefficient in front of the x when we're in slope-intercept form and you'll find it. So the slope of this line is 1/2. What's the slope of any line that's going to be parallel to this one then? Well, if my original slope is 1/2 and parallel slopes are the same, then a parallel slope is also going to be 1/2. That's going to be important to remember today. And if I have an equation y equals -2/3 x plus 5, what's its slope? Well, if I'm in slope-intercept form, again, I look for the coefficient of the x and I find my slope of -2/3. So what's the slope of any line perpendicular to this one? If my original slope was -2/3, perpendicular slopes again are opposite reciprocals. Opposite sign, so my new slope is going to be positive, and reciprocal means to change to flip the fraction upside down, so I get 3/2 instead of 2/3. Positive 3/2 and -2/3 are perpendicular slopes. Let's look at some examples then of what you're going to be doing on your worksheet. Let's write the equation of the line that goes through the point 4, -2 and is perpendicular to the line y equals 4x plus 5. Notice that I'm going to have perpendicular lines. That's important. So first, what's the slope we need to be perpendicular to? In the equation, our coefficient or slope is 4, so I need to be perpendicular to 4. What's the slope that's perpendicular to that slope? Now 4, remember, can be written as 4/1. So if I need an opposite reciprocal, I'm going to change the sign and flip my fraction upside down. That's going to give me -1/4. 4 and -1/4 are perpendicular slopes. So now I have my new slope of -1/4 and the point 4, 2. I have m, x, and y. I'm going to plug those into slope-intercept form. Y, remember, is the y value on my point, m is my slope, and x is the x value on the point. When I multiply -1/4 times 4, I get -1. So now I have -2 equals -1 plus b. And when I add 1 to both sides, I'm going to get b is -1. When all is said and done, I'm only concerned with m and b, with slope and y-intercept, so that I can put those two numbers only into a general equation for the whole line. Remember, I don't use 4 and -2 anymore because that's only one point on a very long line. I want to put just x and y in my final equation to represent every point on my line. Let's try another. Let's write the equation of the line that goes through the point -112 and is parallel to the line y equals -3 minus 8. What's the slope we need to be parallel to? Look for the slope in the equation. I need to be parallel to the slope -3. So what's the slope that's parallel to a negative 3? Negative 3 again. Parallel slopes are equal. So now I have a new slope of negative 3 and a point of negative 112. I have m, x, and y, so I can put that into slope-intercept form. When I multiply the negative 3 times the negative 1, I get a positive 3. And when I subtract 3 from both sides, I find that b is 9. So now I can use only my slope and the intercept to write the general equation of the line. Just a reminder to remember to copy examples and take notes in your notebooks. The rewind function and the pause function can be extremely helpful if you need them, but please don't forget to take notes and bring them to class. I'll see you later. Have a great day.